to do substitution, there's two ways to do this. There's substitution and elimination. I'll do the elimination video later on this week, but for now I'm going to be doing substitution. So during today's video, I'm going to be explaining how to do solving systems of equations through substitution. I'll give you a couple steps of like how to solve it, and then after that I'll do a couple practice problems and I'll set you off on your way. So I'll start off with one, and I'll explain the steps as I solve that one. So our first one that we're going to be doing is y is 2x plus 1. And y is equal to 3x. Okay. And then on the side here, I'll be writing all the steps. So step 1 is to plug in the formula that you have, or the function that you have for a single variable, if that makes sense. So if I have y is equal to 3x, then I plug it in for y on this side. If I had x is equal to something, then I plug that in for this side. So, plug in function with single variable. Okay, so we're going to plug that in. We have y is equal to something. Over here we have y is equal to something. So what I'm going to do is plug in the easiest y, whichever one you think will be easiest to solve. If I plug this in for y, we'd have the 3x is equal to 2x plus 1. And if we plug this in, we'd have the same thing. This is a type of system of equations. So for this one, just because it makes more sense for me, I'm going to plug in y is equal to 3x for this y. So if y is equal to this, and we have a y here, then we're going to plug in the equivalent of y. So we have 3x is equal to 2x plus 1. Then after that, the second thing we do is combine like terms. So we're going to put all of our x's together and all of our single variables together. And if we had other variables, we do that too. But since we only have variable terms and constant terms, which is this is a constant term, then we're just going to combine those like terms. So second step, combine like terms. So here, what the easiest thing to do is subtract 2x from this side and this side. So we're going to have minus 2x, minus 2x. Make sure that when you're doing this, you don't try to like divide by 2 and somehow that gets rid of x. I've seen some people do that, or I'll see people try to like add this 1 with a 2x and think that that makes 3x, but you can't do that. Let's like make a little analogy for this. Let's say 2x, the x stands for apples. If I have 2 apples plus 1 orange per se, can I add oranges and apples? No, we can't. But if I have 2 apples here and 3 apples here, I could subtract 2 apples and subtract 2 apples, if that makes sense. That's my little analogy that I use to teach people usually. So 2x minus 2x is 0. Bring down the plus 1. On this side, 3x minus 2x. So the x's stay the same. But since we have 3 minus 2, we get 1. So we just have 1x. So then let's simplify. This 1x can just be written as x is equal to 0 plus 1 is just 1. So x is 1. So then our third step there was to solve for our variable. There we go. So that's basically how we do those. So then after that, what I'm going to do is plug it in to solve for it. So if we know that y is 3x and x is equal to 1, in order to find y, all we're going to do is plug in this x for the y function. So let's do that now. Wow, I'm out of space here. What I'm going to be doing is I'm going to put the ordered pair right here. It's always x comma y. Since we already have our x, I'm going to plug it in. 1. Now we're going to try to find y. So let's do that. So our y. If we have y is 3x, but we know x is 1, then we have y is equal to 3 we would plug in x there. Since we know x is 1, we plug that in, and we know that y is equal to 3. So that would be our ordered pair that is pretty much the solution to both of these functions. I hope you got that worked down. Now what I'm going to be doing is just pretty much proving it. It's how to check your work. So what we're going to do is plug these two in for this formula, and if they're equal to each other, it's right. And we're going to do it for this formula as well. If they're equal to each other, then it's right. And if it's the same for both, then that means we have the right answer. So let's plug it in here. Remember x comma y. Hope you can see that. So here we have 3 is equal to 2. X is 1, so 2 times 1 plus 1. 3 is equal to 2 plus 1. 3 is equal to 3. That checks out. So that means that this ordered pair here is the solution for this formula. It makes it true. Now we'll start for y is equal to 3x. Okay. So we have 3 for y is equal to 3. We plug in that 1. For x. 3 is equal to 3 times 1 is 3. That checks out as well. Then that means that this ordered pair, this point, it'll be on a point on a plane. This point is true for this, and it's true for this. Therefore, it is the solution for the systems of equations. I'm going to also be showing you right now real quick another way that you'll see them written. Same thing. So something you'll see for these to be written, you'll see something like this. And then you'll have y is equal to 2x plus 1. Y is equal to 3x. This means the system of equations. What you're going to be doing here again is solving for the ordered pair that makes these two systems of equations true. So we have 1 comma 3. We found out that it's true. So our answer to this would be 1 comma 3. Whoa. There we go. So this is just another way you'll see it written. This is more spatially. You'll see this when you're learning it. Once you get it down, they'll write it like this just to make it quick. It's telling you that it's a system of equations. So after this, I'll be running through a couple quick examples. I'll leave the steps up there just for this next example, and then I'll take them down to have more space. So for this one, we have y is x plus 2. And x is equal to negative 3, right? Yes. Okay, so now what we're going to do, again, you're doing the same thing. Since we have a singled out variable, we're going to plug it in for the variable on this side. So they give us x. They tell us x is the same exact thing as negative 3. So what I'm going to do over here, everywhere I see an x, I'm going to plug in a negative 3. So we write that down. Y is equal to, we see an x here, plus 2. We're going to plug that in now. So we have negative 3. Y is equal to negative 3 plus 2. If I have negative 3 apples and I add 2 apples, then I only have negative 1 left. So y is equal to negative 1. Let's do our ordered pair. I'll do it over here again. So we know that y is negative 1. They told us x is negative 3. Boom. Solve for this one real quick. Fact check it, prove it. So we're going to plug it in for this first one. So y is equal to, whoops, I should have plugged in the y now. Y is negative 1. So negative 1 is equal to x plus 2. Our x is negative 3 plus 2. Remember, negative 3 apples, we add 2 apples, we have negative 1 apples. Negative 1 is equal to negative 1. That checks out. Over here we have x is equal to negative 3. So we're going to plug in something for x, which is equal to negative 3. We know that x is negative 3. So we have negative 3. And negative 3 is equal to negative 3. So that checks out as well. And so, as you can tell, we plugged in function with single variable. This is the function with a single variable on one side. We plugged it in. We combined like terms. We didn't have to here, but if we would have had x's, we would have combined them. Solve for our variable. When we did it earlier, we solved for y to find what y was, And then after that, that gave us our answer, and then we checked our work. So I'll be running through 2 more real quick, and then we'll be on our way. And there's instances where you'll end up with like no solution or an infinite amount of solutions. I won't be going over those problems here today, but if you want to know more about them or you want me to do a video on them, leave a comment below and I'll definitely get to that. So our next example here, we have 4x plus y is 2. And x minus y is 3. Okay, so don't turn off the video or try to go away because it's scary. This is actually going to be quite simple to solve. So don't panic. All we have to do is for one of these two, single out a variable so that we can start with step 1. The easiest one I see here would be this one, because over here we're going to do a bunch of dividing and all kinds of crazy work. But over here, all we'd have to do is add y. X is equal to y plus 3. Do you see how I did that? So if I ever have one that doesn't give us a specific single variable, you just do a little quick work to solve for one variable to get it alone, and then this is what it's equal to. It's equivalent. So then for x, we're going to plug that in over here. So we have 4 times whatever x is equivalent to, y plus 3, plus y is equal to 2. Here we're going to distribute. Remember how to distribute. You FOIL it out to every single term. So we have 4y plus 3 times 4 is 12. Plus y is equal to 2. Here we go. Combine like terms. Step number 2. We have a plus y, 4y. We know that if we have 4 apples and we add another apple, then we have 5 apples. We bring down this plus 12 is equal to 2. After this, what we can do is subtract 12. Subtract 12. 5y is equal to 2 minus 12 would be negative 10. We divide by 5 there. Divide by 5. Negative 10 over 5 is just negative 2. So we know that y is equal to negative 2. Yep, so I'll be doing our ordered pair over here now. If y is negative 2, we plug that in over here. Now we want to figure out what x is. So for our variable x, I'll give you a couple seconds to write that down real quick. So what we're going to be doing for our variable x is taking our y, because they don't tell us exactly what x is, but we get a formula. We created our formula for what x is equal to. We're going to plug in the y value to as I said, we're going to plug it in to find what x is equal to. So let me erase that real quick. Yeah, we got that. I was getting scared there that I erased the y value, but I realized I already put it into our ordered pair. So we have x is equal to negative 2 for y plus 3. Negative 2 apples plus 3 apples. So we have x is equal to... So the negative 2 plus 3 is equal to positive 1. So x is equal to positive 1. Boom. So now what we're going to do, I'm going to erase this now. What we're going to do now is plug them in to check our work, and then we're done. So over here we have 4 times our x value plus our y value is equal to 2. Okay. So what we can do here, since we have a plus negative 2, we can add 2, because positive 2, negative 2 cancels out. 4 times 1 is 4, is equal to 2 plus 2 is 4. That checks out. And then I'll do the other one down here. We're not going to use this one, but I'm going to use the original one so that you see that it satisfies the original 2 equations. So we have x minus y, 1 minus, be careful here, negative 2. The reason I say that is because a lot of people will often see a negative sign and they'll see a minus and they'll drop the negative sign on their constant. Make sure you don't do that. If you see minus negative, put it in parentheses. and then is equal to 3. So we have negative minus a negative, so we do same, change, change. This stays the same, positive. This changes to a plus. This changes to a plus. Is equal to 3. So 1 plus a positive 2 is equal to 3. 3 is 3. Check. It checks out. So our ordered pair, 1 comma negative 2, is the solution for our two original functions here. Okay, so I'll be running through one more quick example, and then we're done. Let me try to find a tough one if I can. Okay, guess I can't find a tough one. That one's pretty hard. Let's try that one, number 10. Okay, so for this one, we're going to be trying negative 7x plus 2y is 18. Okay? And then 6x plus 6y is 0. Okay. So for this one, let's see. Which one is the easiest to solve for? Ooh. I mean, I don't know what you guys see here. If you did like the work for here, you'd have a lot of dividing and stuff. Here, it looks a little bit easier, not by much, but I'm going to stick with this one. Now here you could solve for 6x or 6y, doesn't make a difference. I'm going to be solving for x just because I want to. That's my only reason for it. So to single out x, we're going to subtract 6y from both sides. So 6x is equal to negative 6y. In order to get x alone, we divide by 6. Divide by 6 on both sides. X is equal to negative y. Okay, so that means that what I'm going to end up doing is for every x I see over here, I'm going to plug in a negative y. So I see an x here, negative 7 times negative y plus 2y is 18. Negative 7 times negative y is a positive 7y, because negative times a negative is positive, plus 2y is equal to 18. 7 apples plus 2 apples is 9 apples, which is equal to 18. Here, in order to single out y, we're going to divide by 9. And I hope you see why I'm dividing by 9. Remember, like, back in, I don't know, maybe middle school probably, you would do the inverse operation, so multiplication would get undone by division, subtraction would be undone by addition. So because technically here we're multiplying the 9 and the y, in order to undo that, we're going to divide. Opposite of multiplication is division, so that's why we're doing that. 18 over 9 is 2, so y is equal to 2. So let me erase all of this work. I hope you wrote it down. If not, you could always pause the video for sure. That's a nice thing about YouTube. And then we'll do our ordered pair. I'm going to do it over here this time. So y is equal to 2. Now we just want to find what x is. In order to find x, all we're going to do is plug in our y value for the y, and that gives us the answer for x. So x is equal to negative y. Y is 2. We plug that in. X is equal to negative 2. Then again, all we're going to do here is solve for our both functions to see which one is right. So again, I'm going to be using the original two functions. So what we're going to do here is negative 7, plug in the x, negative 2, plus 2, why did I do that? Why did I do that? Plus 2. For y, we plug in our y value, which is 2, which is equal to 18. Negative 7 times negative 2 is, again, a positive 14. plus 4 is equal to 18. 14 plus 4 is 18, which is equal to 18. That's correct. Now I'm going to be solving for 6x plus 6y, and then I'll set you off on your way. So we have 6 times x. If our x is negative 2, we plug that in. Plus 6 times y. Y is positive 2. We plug that in, which is equal to 0. Negative 12 plus 12 is equal to 0. Negative 12 apples plus 12 apples, that cancels out. 0 is equal to 0, so that is true. Our points for these two functions that satisfy them is negative 2, comma 2, which is x value of negative 2, y value of 2. That's it for this. Later on this week, I'll be releasing solving systems of equations through elimination, which is another way to solve these systems of equations. Make sure to hit like below, subscribe. If you have any questions or comments, leave a comment in the comment box, and I'll definitely get to that. I check it every day, so that's for sure. If you have any requests for specific type of videos, I can certainly do that as well. Thank you, and see you next week.